Okay guys, so if we can look up now, we'll continue. So, no, it's not that bad, don't worry. Yeah, we did completely square last time. Okay, look up. Ready? Yep. So last time we were looking at completing the square, and we saw that in completing the square it's useful for finding the minimum or the maximum point. And what's the name? Do you remember the name of that? Yeah? Vertex, yeah. So what we want to look at now is a bit more general. How do we generally solve and sketch quadratics? So the first way I want to show you is not really the best way to be doing it for the exam, because it takes a little bit too much time, but you can still use it. And it's probably a method that you're all familiar with from school anyways. So the first method you could say is just by using a table. So for example, if I say sketch y equals x squared plus x plus 1, we can do this by making a table. Now, what's not clear is where do we start and where do we finish? You know, like do we start at -3 and go to +3, or maybe we start at -5 and go to +5? So I think what I'll do is I'll just go from -5 to 5. X, y. So here we have -5, and then what we need to do is put -5 into the quadratic and get the value of y. You need to grab your stuff? No problem. Do you need more time, or are you all done? Are you sure? I'm very sure. Okay. Is your wallet? Yeah. Okay, so if we put the -5 in, let's see what we get for y. -5 squared is 25. 25 minus 5 is 20, plus 1, 21 then. Then we have -4, -3, -2, -1, 0, 1, 2, 3. This always happens. 4, 5. Okay. So what I want you to do to get you warmed up and started for the morning, fill this table in for me. That's right. Here, I'll help you out. I'll do one more for you. There now. Let me just open up the calculator as well.
The exam, do you have to show our work?
Nah, I can just put the table down. What's good about this method is that you know, you can use it for any graph. It doesn't have to be quadratic. It's quite flexible. Come on, quick. How are we doing on the table? So do we have the next one? What is it? What's the next one?
13.
30?
Yeah, 1, 3.
Oh, 13.
Yeah.
1, 3. And there is actually a quicker way to do this on your calculator. And if you have the Casio calculator, I want to show you. So watch carefully for those who have the Casio calculator. So you can make this table on your calculator. What you do is you press Mode and pick Table which is number 7 here. Then you type in your formula, and the x is on the alpha x squared plus alpha x plus 1. Then you press equals. My calculator asks me for this, but yours probably doesn't, so we just skip that. We start at minus 5. Yeah, alpha and x makes the x when you're typing the formula in. And we finish at 5. And we're going up in ones. And you see we have the table. So it's 21, 13, 7. Have I gone too far? Minus 2 is 311. 3, 7, 13. And then, yeah.
Do you know where we can get the cashew calculator?
Say again?
Do you know where we can get the cashew one?
I think you can order it from the Easton's bookstore on O'Connell Street. They might have it. A lot of students just order it from Amazon. Yeah. Okay. So we have this drawn. So we can see that the y goes all the way up 30. This is going to be a terrible sketch. 30, 30, y, x, oh goodness, minus 5, 5, 1, 1, minus 1, 0. So it must cross down between. I don't even think it crosses the y-axis. No, because all these are y positive. None of these are 0. Yeah, so yeah, I'd say it might be something like this. Oh, sorry, I meant to say the x-axis. I don't think it touches the x-axis. This one, because all these y's are bigger than 0. I don't think it ever dips down to it. Anyways, that's obviously a terrible graph, because in the exam you'll have a graph paper to plot all these points. So the first one is minus 5 and 21, and then minus 4 and 13, and you go along, make all your points, and connect them. Yeah, that's basic stuff anyways. This isn't really what's due in the exam, except in biology actually. So in biology they'll give you a table of points that you're to plot and draw a curve through them. But more important is the next method. So the next one, I don't want you to sketch it. I want us to look at how to solve something like this. And one way we can solve this is by factorizing. And factorizing is something that we learned how to do. Was it this week? Yeah, it was this week. So two numbers that multiply to make 4 and add to make 5 has to be 4 and 1. So what we did was we factorized. This is where the solving part comes in. So if you really think about this, if I have two things that multiply to make 0, one of them has to be 0. So we can have A equals 0 or B equals 0. Yeah? So you could either have x plus 4 equals 0 or x plus 1 equals 0. Which means x equals minus 4 or x equals minus 1. Yeah. Why? Now, you do have to be careful with your English. Why am I saying or and not and? It's one of the two, yeah. Why can't it be both of the two?
It could be both.
Could it? No, it couldn't.
Couldn't?
Yeah, but here it couldn't be. These couldn't both be 0.
But then it's not crossing the y-axis. That's what you want to find out.
Yeah, but my question's a bit more basic. Like, why can't I stick the word and here? Why do I have to stick the word or? Why couldn't I put and? Like, is it wrong to put and? Or it doesn't matter? It's wrong to put and, but why is it wrong to put and?
There's only one solution.
Well, there's two here, though.
One of them is that one.
Huh? One of them is what? No, don't be shy.
Either one is correct because if either one is zero, the answer will still be zero.
Yeah, but my question is, why can't I write the word and? Why must I write the word or?
Minus 4 then because minus 1.
That's it, Jeff. If it's -4, it's not -1. So you can't say and, you know? You can't be both of these. If I say Stephen is a boy and a girl, you know? You can't, no, I can't really have that, I'm afraid to tell you.
Maybe in 2018.
In maths class we can't have that, okay? Maybe in a sociology class, but not in a maths class. Okay, so that's factorizing. And we can use factorizing here to solve. Let's have a look at another method to solve. So this is our second method, factorizing. And I feel like this is a method you've all seen before at some point. Yeah? So write this down and we'll have a look at our third method. Oh, and I should say, factorizing doesn't always work. It's not something that works all the time. Okay? There are some situations where you can't factorize. Like a very simple example is the one up here. I can't factorize this because I cannot think of two numbers that multiply to make 1 and also add to make 1. Because there's only actually there's only one pair that multiply to make 1. And what's that? 1 and 1. Which obviously can't add to make 2. Okay, so we can't factorize all the time. Okay, write this down. We'll have a look at the next method, which is to use completing the square.
D squared minus 4 is.
No, not that one actually, no.
That's what we learned the other day.
B over 2 squared.
Yeah.
Yeah. Who did B squared B over A squared? No, B over 2 squared.
Yeah, half the middle.
Yeah.
Yeah. Anyways, let's have a look at this one now. So, completing the square as a method. Now, I actually like this method the most for making graphs. And the reason I like it the most for making graphs is because you actually get something else with it. But before we look at the graphs, let's just look at how to actually use the method. So yesterday we did completing the square, or last time anyways. So we know that this will be x plus 7 squared, and then at the back we have 40 minus 49, minus 9. And then you might say, well, that's not, how is that helpful into solving the quadratic? Well, you see, what we can do now, which we couldn't do previously, is we can take this 9 to the right and get something quite easy to solve. Yeah, x plus 7 squared equals 9. Or maybe to make it even more clear, I could say x plus 7 squared equals 9, but 9 is 3 squared. So, x plus 7, yeah, is 3. Also minus 3 it could be as well. You have two possibilities, yeah. Because you have the square root here.
Isn't it better, like, instead of changing it into like square, you just move the square over, so it becomes plus or minus roots?
What do you mean by no? Stop, pause. I understand what you're talking about. Everything makes sense except the word better. What do you mean by better? Like, how would it be better?
Because then you have the plus and minus.
But I'm just about to put in the plus and minus. Relax. Plus and minus is about to appear. Dun dun. There we go. So, we have two possibilities here. X plus 7 equals plus or minus 3. So now we have x equals minus 7 plus or minus 3. So we have two possible answers here for x. We could have minus 10, or if I use the plus 1, minus 4. They're the two possibilities here. Okay. Let's have a look here. Continue?
Yeah.
Yep. Right, so let's go back to sketching now. So let's say you had a question and it said sketch y equals x squared plus 16x plus 64. Okay, well let's try and think about this. How did we sketch the line? We sketched the line by finding the x and y intercepts. The easiest one to get first is the y-intercept. So, let's start by saying let x equals 0, so what will that make y? Y will be 0 plus 64, which is 64. So we have 1 point already, 0, 64. Okay, next, the x-intercept, also called the roots, let y equals 0. So that means we have x squared plus 16x plus 64 equals 0. Okay, two numbers which multiply to make 64 and add to make 16, 8 and 8. So x equals minus 8.
What method is this?
Factorizing. Yeah. But I want to find both the x and y intercepts to make the graph. So I have x equals minus 8. So I have minus 8, 0. Okay, let's make the graph now. X, y, 0, 64. So that would be there. And then minus 8, 0. That would be there. And there's only one way I can draw this. Like, for example, why would it be wrong to draw it like this? Yeah, if I drew it like this, then I'm suggesting there's another root here. But I could only find this one. So whatever way I draw it, I have to draw it so that it only touches the x here. And the only way I can imagine drawing that is if it... the vertex is at minus 8. If it just about reaches minus 8, but then immediately comes back up.
So minus 8 would be the minimum.
It will be the minimum, yeah, the vertex here. Yeah.
It's possible to use completely the square root.
Yeah, that's what we'll look at. The next method is completing the square to graph it. So write this one down. Like I said, the completing the square method will be my favorite method because it gives you the vertex as well.
Sorry.
Yeah.
You were given an equation where instead of, here you only have one value of x. But you're given one in which there are two values of x, that's the factorization. So how do you...
Yeah, if there were two values of x, you plot the two values, the y-intercept, and you should still be able to get the quadratic in it. Okay, can I go to the next example? Okay. Now I should tell you that this method, or this example here, is the best method to use. And the reason for that is because in the previous method, it worked quite nicely because I could factorize it. And I could find a factor, a root. But of course that's not always the case. You remember I said earlier that sometimes you don't have factors. So what's nice about this method I'm about to do, the completing the square, is it should always work to give you points to make a graph. Okay, so let's have a look at this one. I should take out 2 first. So I have x squared plus 16x plus 137 over 2. So I have y equals 2 x plus 8 squared. Now don't tell me. 137 over 2 minus 64 minus 120. Is it 9 over 2? Now you can tell me.
Yes.
Okay. It's disturbing that I'm quicker than the calculator. If we really think about it, you shouldn't be happy with that. You should be very unhappy with that, actually. Okay, so multiplying by 2, x plus 8 squared plus 9. Now, let's begin. So, let's first find the y-intercept. So, if I find the y-intercept, I'll say let x equal to 0, and then what will y equal? It will be 137. You can see this most clearly actually back at the start. Okay, so we have 1 point, 0, 1, 3, 7. We also have the vertex. What's the vertex here from this one? Minus 8, 9. And is it min or max? Minimum. Because the positive 2. And lastly, can we get the roots? Well, we actually can't, and let's see why not. If we try to get the roots, we immediately hit a problem at the very beginning. So what's the problem here?
It's a negative.
Yeah, why is that a problem?
Because the roots usually plus or minus, right?
Well, more serious than that.
The square root will be positive.
Yeah, because you can't say something squared is negative. Like, you're not allowed to say that at the moment anyways. So, this one here has no roots, which means it definitely would have had no factors. It had no roots. But that's okay, because we have 2 points, and we actually know one of them is the vertex. So, if I was to draw this here, this would be 137. This would be minus 8. It's a minimum, and it just goes up to 9. So the graph would be something like this, and that point there is a 9 then. Obviously that's not to perfect scale. But anyway, this is the safest method in the exam. And then, in fact, sometimes in the exam when they ask you to make a sketch, they actually say in the question to show the vertex, which is this point here. So this method is the only one that would let you do that. Okay. So write this down, please.
Seems like we have a lot of graphing to do.
No, I'm just giving you different methods. Because, for example, if you were asked to graph a quadratic and you could see straight away what the factors are, then I would probably just get the factors and graph it that way. If I couldn't see what the factors are immediately, then I might be thinking, oh, I better complete the square. And certainly if it asked me for the vertex, I'd complete the square. So really, I'm giving you different methods so that you can choose the one which is quickest for the question that you're given.
So they don't really specify in the exam? Or?
They don't specify. I think maybe once they said part A, find the factors. A couple of times they would say A, find the factors, and B, graph it. So it's kind of implied that if you just found the factors, to save time, you just use that answer to make the graph. But there'd be nothing wrong if you then completed the square. You're just making more work. Yeah.
Kind of use the formula minus 3 over 2 to find out what
That gives you the x.
x coordinate and you substitute.
That's fine. Just in your answer, just write use formula x equals minus b over 2a. If you've seen this formula and you want to use it, that's fine. Yeah.
Now the root kind of use the delta root.
Yeah, we still have to study that, but yes, that's the next lesson. But you could use that. Yeah, you could use that if you know it already, which you do. Yeah.
How do you minus 8, 9?
Oh yeah, that's what we did last time. when we want to find the vertex when it's in completed square form, you take this one here and make it 0. The only way to make this 0 is if x is minus 8. And when this is 0, you're left with 9 for the y. So this is from the previous lesson. Anything else on this? No? It's not too difficult. Not too difficult. Usually in the exam they only want a sketch, which means you can just draw it neatly in your answer book. Sometimes they want a plot, which means you have to use graph paper and draw it very accurately. Okay? Yeah, they would. And it'll be clear. If they say plot, you have to use graph paper. If they say sketch, you don't have to use graph paper. Okay? I think actually that maybe it's worth just writing down for people who didn't hear it. So the verb sketch and plot. This one means you have to use graph paper. And this one here means no graph paper. Okay. Okay, so probably yeah. Sure, I could give you loads. 20, 30? How many would? Oh well, be careful because there's 100 plus here if you want that many. Let's stick with what we're doing. First and last in each. First and last in each. Question, yeah. Can you just pass your name and class for it?
Sorry?
Yeah.
Sorry.
Yeah. Question, yeah. You need to talk down. I'll get you one now. What do you need for the next hour then? Yeah, it's right here. Yeah, it's right here. I'll copy a book for you then.